Hi class, welcome back. Today we're going to be going over lesson 4, which is determining the equation of a parabola. Before we get started, your homework questions are going to be page 123, 1, 2, 5, and 6. Just a heads up, number 5 is a harder question, so try it, but if you don't get it right off the bat, try and look up the solution, and we can go over it in class as well. But number 5 is a harder question, so I definitely would give that a shot just to make sure that you understand and you know how we're doing our notes in this class, or how we're doing what you should know by the end of this class. This lesson's pretty straightforward. We're going to be determining the equation of a parabola. The only learning goal for this one is you're going to determine the equation of a parabola given information about its vertex, any vertical stretches or compressions that it might have, and also I forgot to add one thing, right? Given a graph or point. Right, so basically you're going to be given some information and you're going to be able to determine that the function or that equation. So just for us to remember, in vertex form, the form of a parabola is going to be y equals a bracket x minus h to the power of 2 plus k. So we're going to go over and we're going to actually talk about what each of those variables mean. Right, so y and x are just points on the graph, but more importantly, when we start off, a over here actually represents, if we remember back to our roles of a, h, and k, this represents any vertical stretch or compression, and it also represents the reflection. So if it's a negative, it's going to be the reflection. If it's positive, it's going to open upwards. So I would even say opening direction. So if it's negative, it'll open down. If it's positive, it'll open up. So let's do that. So if A is greater than 1 or negative 1, right? So if a is an integer, you're going to have a stretch. If a is a fraction, you'll have a compression. And then if a is positive, it'll open up. And if a is negative, it'll open down. Right? These are kind of just our rules. So that's for A. Let's move on and talk about H. H is going to be the horizontal shift, right? And it's horizontal because it's inside the bracket right beside the x, so this is the horizontal shift. So it's how it moves across the x-axis. This is also H, is also the x of the vertex. We'll talk about that later. And then last but not least, we have our k value, and our k value represents the vertical shift. Right? This is how it moves up or down the vertical axis. So this is up or down. So if I say something's translated up or something's translated down, right? That's the language you're going to use for that, and for horizontal, left or right. Another thing to remember, the vertex is H and K. Okay? So that is just a quick summary, and now we're just going to go in and use this information in order to actually solve our problem. So let's do an example number 1 together. So it says, find the equation of a quadratic function that has been stretched by a factor of 3, has a vertex of 3 and 6, and opens upwards. So what we're basically trying to do here is convert these words into some way of us understanding what it is in terms of mathematics. So we're taking English and we're turning it into mathematics. So let's just start off with this one. It says, find the equation of a quadratic function that has been stretched by a factor of 3. We know that out of A, H, and K, our stretches are represented by this A value. So I'm going to label this as A is equal to 3. That's what that line is saying. It's telling us A is equal to 3. And then it has a vertex of H and K, right? So we know that it has a vertex of 3 and 6. So 3 and 6 are going to be our H and K values, right? So I'm going to put those in different colors just so that they're consistent with the top one. So we have 3, and then we have K, which is 6. So then this is H, and this is K. So our H value here is going to be 3 as well. And our K value is going to be 6, right? And then it says it opens upwards. We know that when something opens upwards, right, it is a positive A value. So we're just going to leave our A as positive 3. I don't need to go right in the positive. I'm just writing it in for the sake of clarity. So now what we're going to do is we're going to go back to our original equation, which is y equals a x minus h squared plus k, right? And we're just going to sub in what we know. We don't know what y is. We're never going to know what x and y are because they're just random points in the graph. Our a is 3. Our x, we don't know. Our h is 3, so it's going to be minus 3 squared plus 6. And that's going to be the equation of my line. Positive 3, right, is my a value. Sorry, I'm just going to put this in a different color, maybe blue. And that's our equation of the line. Okay, so positive 3 is my a value. Positive 3 is my h value. So if I pulled this 3 out of this equation, I would know it was, you just have to switch the sign when it goes into the bracket, and then plus 6. Okay, so try doing this one by itself. This one says that it's compressed by a factor of 1/2, translated down. So you want to go back here and be like, which one is responsible for going down? We know it's K. And then it opens downwards. So pause the video, try doing this one by yourself, and then we can take it up together. All right, so we're going to take this up now. So it says the equation of a quadratic function has been stretched by a factor of, compressed by a factor of 1/2, right? And we know if something's a vertical compression, it's a fraction, right? So then we know that this is A. A is equal to 1/2, sorry, is what that sentence, that blue sentence is going to say, 1/2, right? It's translated down. So out of K and H, the only thing responsible for going up or down is K. So we know K is 5. K is 5, right? And it opens downwards. And the thing that tells us if something opens up or down is going to be, again, A, if it's positive or negative. And if it opens down, it's going to be a negative. So we're going to say A is negative. I'm just going to go throw that negative sign in front of the A. So now I know A, I know K, and if I don't have something for H, I'm just going to assume that it's 0, right? Because there's no horizontal shift, H is just 0. Okay? Because I'm not adding anything to the X value. I'm just adding 0. So then, same thing. We're just going to go back to our original formula, and we're going to go, okay, y is equal to A x minus h squared plus k. And let's go sub in what we know. We don't know y. We know 1/2 is A. I know h is 0, so I'm just going to write minus 0 plus k, which is 5. This whole like x minus 0 situation, don't necessarily like how it looks, so I'm going to simplify it and write it as x squared plus 5. You could also write this as without the brackets. I don't really care which way you write it, but it's probably better if you write it without the brackets. But if you think it looks cleaner with the brackets, that's fine by me as well. And that's your answer. So therefore, y is equal to that. Cool. Oh, and sorry, it's translated down, so it should be -5. I apologize. Silly me. So then this should be negative 5. If it was translated up, then it would be positive 5. Okay, so that's my answer. So now we're going to try and do example number 3 together. It's a little bit different because now what we have is we actually have points on the graph. We don't necessarily have what the vertex is. We have to find it from the graph, which is easy. If you go and look at the graph, you go and you look at the top over here, and you're going to say, okay, what's the x value here? 2, right? Because when you're writing coordinates, you always write it as x and y. So I'm going to write x, y, 2, and then 4. 5. So 2 and 5. So I know that my coordinates at my vertex are 2 and 5. And I know that my vertex is indicated by h and k. So I have my h value and I have my k value. Right? So when you're doing something like this, it's actually what you should do, and there's a step-by-step process of finding these, right? The first thing you should do to determine to do this is that you need to know everything that you have already. We need to find what the value of a is, right? So that's what we're ultimately looking for, and we want to find that whole entire equation. So the steps that you are going to follow here are as follows. You're going to determine the value of a, right? So first things first, you're going to determine the value of a. Then you're going to substitute another point. So you're going to take either x or y that's different than the vertex. So you're not going to use 2 and 5 again. You're going to use another point on the graph. Then you're going to write the relation using the vertex and the value of a. Right? So what you're going to do, let's do this step by step. I'll go through them with you and I'll give us a little space to go through it. And then I'm going to just carry this over here so that we have enough space to solve because it is a little cramped here. Okay, so let's go in and determine the value of a. The first thing we need to do is we need to substitute, right? And another point for x and y. So let's find another point on this graph. You can either use -2, so you can use either one, you're going to get the same answer. You can use -2 and -3. Personally, I hate using double negatives, so I'm going to use this one. I'm going to use 6 and -3. Right, so I'm going to use 6 and -3. Those are just the points that I like, and I'm going to substitute what I have. So again, I'm going to go back to my original equation. I'm going to say, okay, y equals a h minus x minus h plus k. Right, I know my y value is -3, right, just from that point on the graph. I don't know what my a value is, so that's what I'm still looking for. I know my x is 6. My h is 2, right? Minus 2 squared. And then my k value is 5, right? And I just get that from the vertex plus 5. And now I have all this information, right? And I'm just going to use it to help solve my equation. I'm just color coordinating so you see where I got them from. I got the -3 and the 6 from here, right? This x and y, and then I got the h and the k from the vertex. Okay, so you have that, and now I just have to solve for a in order to find out what my a value is, right? So let's go do that. Always do brackets first, so I have -3 equals a, 6 minus 2 is 4 squared plus 5, right? -3, then you got to do the exponent, so 4 squared is 16 multiplied by a plus 5, right? I want to bring the 5 over to the other side, so I'm going to subtract 5 on both sides. Subtract 5, subtract 5. -3 minus 5 is going to be -8 is equal to 16a, right? And I want to get rid of that 16 in front of the a now, so I'm going to divide both sides by 16. So I'm left with -8 over 16, and then I can just simplify that. I know that's going to be -1 over 2 is equal to a. So now that I have the a value, it's really easy. Now I just got to go back in, then write the relation using the vertex and the whole value and the value of a. So now I want to go back and get rid of that x and y, because normally when I write my equation, I don't have x and y. So sub in everything except x and y. Okay, so let's do that. So I have y equals a x minus h squared plus k. So I'm not subbing in y. My a is negative 1 over 2, which makes sense. It's facing downwards. X, which I'm not going to sub in because I'm not putting in x and y. My h value was 2 plus my k value, which is 5. And that's the equation of my parabola. Okay, so they're very simple steps. The first thing you need to do, you need to find the value of a. How you're going to do that is you're going to find your vertex and you're going to find any other point on the graph. So find your vertex, find any other point on the graph, substitute those values in, isolate for a, and then rewrite everything in terms of x and y. Right, so sub everything back in except for x and y. So I'm going to show you, we're going to determine the formula for the vertex or the graph below. So again, try to do this on your own. Very similar to our other graph. Go in, find a point on the graph. Find one that kind of goes through something really clearly. It'll just make things easier for you instead of having to guesstimate where the point is going through. All right, so I'm going to go ahead, pause this video, take a second, try to solve it yourself, and then hopefully you pause and we're going to take that up, okay? So first things first, you're going to go in. Step 1 is always find your vertex. Find your vertex, and that will give you h and k. Right? It's just the easiest thing to do right off the bat. Where's the point where it turns around? Right there. So I know my vertex is, so vertex is equal to, x is going to be 1, y is going to be 5, right? You're just going to go find the values where they intersect. So then I know that my h value is 1, and my y value, my h value, and my k value are like that. So I know h is equal to 1, and I know k is equal to 5, right? Easy peasy. So then if I have my h and I have my k, right, then I'm going to say, all right, now what I need to do, it says step 2 is determine another point for x and y that is different from the vertex and solve for a. So step 2, find another point, x, y. So I'm just going to go in and highlight these. I like to just keep these steps. You obviously don't have to write this in. It's just for clarity's sake. So let's find another point on this graph. There's a few that we could use. I'll show you what they are. I personally went with the one that was easiest to work with in terms of numbers. You could have used 2 and 2, right? And you don't always have to do it the same way I do. You can use this one, 0 and 2. This is the one I use because 0 is an easy number to work with. Or you could use negative 1 and 0, right? Also, 0 is an easy number to work with. It just depends on which one you choose to use. It's completely up to you. So I'm going to use 0 and 2, but you can use any of those values. So I use 0 and 2. So step 3 is going to be sub 0, 2 for x and y, and sub 1, 5 for h and k. Right? So I'm basically going to say, okay, my x is equal to 0, my y is equal to 2, my h is equal to 1, and my k is equal to 5. And I'm just going to sub that into y equals, and I'm just going to highlight this, y equals a x minus h. This is just a basic equation. Okay? Right? So let's plug our numbers in. Y I know is 2. And you know what, I'm going to put these in different letters so that you see where they're all coming from. So maybe we'll put these in this orange color. So y is equal to 2. It came from one of the points. We don't know what a is, right? X is equal to 0. We know h is equal to 1 squared plus k, which is 5. So just going back in and putting them in from the numbers that we found and how we found them, just so you have an idea and understanding of where those numbers came from. This is our h value, and this is from our x and y. Okay, now you can just go in and do the math. Let's just isolate for a. So first things first, you're always going to want to get the 0 minus 1 sorted, so that's going to become minus 1 squared plus 5. 2 equals a 1 squared is just 1 plus 5, right? So then we're going to bring the 5 over to the other side, so 2 minus 5 is equal to a, or 1a. Divide both sides by 1 if you have that 1 there. But if not, when you divide anything by 1, we just assume that it's gone. So 2 minus 5 we know is going to be negative 3. So our a value is negative 3. And then step 4 is just rewrite your equation without x and y. Right, so rewrite your equation with x and y. So I'm going to say y is equal to ax minus h squared plus k, right? Don't know what y is. I know a is negative 3. I don't know, we're going to get rid of the x. H I know is, h we said was 1 minus 1 squared plus k, which our k value we said was 5. And that's my answer. Okay, so again, there's 4 steps to solving this kind of a problem. Normally there would have been 3. It's just you have to take that whole extra step of actually finding the vertex, finding a point on the graph instead of it being given to you. And that's really the new thing that you need to know from there. So again, try 5 on your own, similar problem, right? And now it says that find the equation of a quadratic function that has a vertex of 2 and 4 and passes through point 2, 8. This is a situation where you're given your h, you're given your k, you're given your x, you're given your y. You just have to find a and then find the equation of the line. So you don't even have to go in and find it. Everything's kind of been given to you. So let's just go right down. Here's our h value. Here's our k value. Right? And then here is our x and y values. Right, so let's just go in and put in what we have and work with that. So we have h, which is equal to negative 2, k, which is equal to positive 4, x, which is equal to 2, and then y, which is equal to 8. So I'm just going to go back to my y equals a x minus h squared plus k, and I'm going to plug in what I know. I know y is equal to 8. I don't know what a is. I know x is equal to 2 minus, and then h is negative 2. So then that's a little bit different because you got to make sure it's negative 2 plus k. Right? So a is equal to a. 2 minus negative 2. If you even put that into your calculator, you'll get 4. Because this negative and this negative cancel and become a positive, so it becomes 2 plus 2. Plus k, which we know is 4. Sorry, I didn't replace that here. Plus 4. Right, so let's just do the math. 14 squared is 16 plus 4, right? So then I want to bring the 4 over to the other side, so I'm going to subtract 4 on both sides. A is equal to 8 minus 4 is going to be 4, is equal to 16a. I want to get rid of the 16 in front of the a because I want that by itself. This will cancel. 1 over 16 can be reduced into 1 over 4, which is our a value. Okay, so if that's our a value, our last step is y equals ax minus h squared plus k. Right, let's go put in what we know. We don't care for y. We know a is 1 over 4. X minus negative 2 plus k, which we know is 4. So then we have y equals 1 over 4. We're going to take this and turn it into a positive, so it's going to become x plus 2 squared plus 4, and that is my final answer. Okay, so that is how we solve and how we take basically the parabola and we change it into where we take either the vertex or some point or some graph of the parabola and we turn it into an equation. So what we've been doing so far is we've been graphing the parabola and been like, okay, how can I make an equation out of this? Or like I give you an equation and you'll be like, okay, how can I use this equation to find out what my graph will look like? Then today we went the opposite way. We said, okay, this is what our graph looks like. What's the equation? Right? So now you can switch between the two. And that's the point of this lesson. All right. Could you please, if you're watching this and you haven't done the exit ticket number 5 and 6 for homework during your asynchronous period class, could you please hand in example 5 and 4 as an exit ticket so that I can mark it just to make sure that you understand this concept? And that will be due at the end of your asynchronous period on the 13th of May. All right, so on Thursday in the middle of your asynchronous period, or at the end of your asynchronous period, that is when that is due. All right, I'm going to stop this.